Start with adding and subtracting. Now these are basically fractions with algebra to them. So the rules for fractions still apply to these guys. So for adding and subtracting rationals, the same rules apply that apply to adding and subtracting fractions. What do you need when you're adding and subtracting fractions?
Fraction. Is it a variable?
What do we know? What do they need to
Like
have?
3x squared.
No. If I gave you like 1/2 plus 1/3.
No common denominator.
Common denominator. Reciprocals are for division. Okay? So yeah, you need a common denominator. So that's where this gets a little tricky. Okay. We need to find a common denominator before you can combine them. Okay? So when I say common denominator, we all know that means the bottoms have to look the same. Okay? A little more complicated now with algebra, but it's not too bad.
Do we still get to do the cross thing?
After, yes. Okay? I'll show you what that all looks like here.
You also forgot an E on before.
What's that?
You forgot before on.
So, let's do an example here. Yeah, let's start with this one here. 2x all over x plus 4 plus 8 over x plus 4. Now, looking at this, are my denominators the same? Very good. That's the first step. All right, yes or no question, check the box. If it's yes, you combine things. So when it's a common denominator, you can actually write everything over one denominator now. So it looks like this. 2x plus 8 all over x plus 4. Because remember, when you add fractions, do you add the denominators together?
No.
No, right? So you can just write it over that. Now, can I combine anything here? Can 2x plus 8 be made into anything? No. If you wanted to, you could get fancy. I could take a 2 out of everything on top, though, right? And it just becomes, right? And x plus 4. Then if I have an x plus 4 on top and bottom, what do? Cancel them out. Okay. It's very satisfying.
No, it's just a...
Yeah. Okay. What I like about this example, it demonstrates what a common denominator looks like. It shows you how to add up with a common denominator. And then I show you that I can still cancel stuff out.
I'm assuming that's one of the easiest questions we like to do.
Absolutely. Of course, that's the first example. I wouldn't do the hardest one first. Then everyone would be running for the door, signing up for Workplace 10 or something. This way, I got you. So, now I'm just going to bump it up a notch with the first one. And let's do something like 2x over x minus 3 minus x minus 1 over x minus 3. Another easy example. The trick with this one now is when I combine stuff, I have a common denominator, right? So what it does is it looks like this. 2x minus all of this, right? All over x minus 3. Subtraction's tougher than addition. Because once you throw in a negative sign, what does it start to do to everything? You're going to change signs on everything. Basically, everything after the negative sign now, I have to change its sign because I have to subtract everything, right? So it becomes like 2x take away positive x. Looks like 2x take away x. 2x take away negative x. What does a negative and a negative do? Right, so it becomes 2x minus x plus 1.
That's all.
Well, now I look and see what I can combine. Yeah, like 2x take away x. That's just going to be... And then this one's done. I can't simplify it beyond that. What's wrong, Maddie? Okay.
You can't take out X out.
No, the x would have to be like in everything. Technically, like this is one number, and this is one number. Does this part here, changing the sign on everything after the minus sign, make sense? That will be the hardest part of today's lesson. Oh, good. Someone's here.
Where did the 2 go? You have the 2 halves.
The 2, what's 2x take away x?
Oh,
1x. Okay? You just need to remember the big thing, switch the sign after, everything after the minus sign. Okay? All right, let's kick it up a notch here. Let's go with something like this. X squared minus 20 divided by x squared minus 4 plus x minus 2 x plus 2. What's that?
You can get 2x plus 2 out of x squared minus 4.
Difference is square, right? X minus 2, x plus 2. Good. With these ones, now that it's a little more complicated, factor everything as much as you can first. X squared minus 20, I can't do anything with that. So that just stays as it is. X squared minus 4, that's a difference of square. Right? This I can't do anything with either. Now, as of right now, I'm not trying to eliminate anything. I'm just factoring it down to see what I have. See how I'm not trying to cancel things out?
Yeah.
Does anyone have any questions where these numbers here came from? You guys want me to scroll up a little bit so you can see it there? Is that okay with everybody there? All right. Now, I need a common denominator. Let's look at the first one. My first one has an x minus 2 and an x plus 2. Okay. This one here just has an x plus 2.
You can cross out x minus 2. Just get rid of them.
Oh, no. We can't cancel anything out here. Right? There's no x minus 2 here to cancel out top and bottom.
When you do the diagonal.
No, you can't yet. No. So just watch. So your common denominator. I'm trying to see what I have. I need them to both be the same. This one has an x minus 2 and an x plus 2. This one only has an x plus 2.
So
So what do I do when I need a common denominator with fractions?
You add it.
You multiply.
You put it on the side.
So I got to multiply this now by x minus 2 as well. Now whatever you do to the bottom, you have to do to the top as well. So my common denominator here is x plus 2, x minus 2. Okay? That kind of makes sense? So now, my common denominator, I can write that out on the bottom. So now this part here, notice how I don't do any FOIL to the bottom. Ever. Don't work out the bottom. Always leave it in factored form. Up top, though, I'm going to have x squared minus 20 plus, I need to do the FOIL here, though. Okay? So, x squared, or x times x squared, thank you. X times negative 2 is negative 2x. Negative 2 times x. Negative 2 times negative 2 is?
Don't you just, so you have to write it like that, you can't just put negative 4x.
No, you could. I'm just showing all my steps. If you want, like, you could, like, show your, like, just combine everything if you wanted. I'm showing extra steps because this is the first time out. So now that I've done all the FOIL, what's nice here is because of this addition sign, I don't need to worry about my signs on anything. Everything just stays exactly how it was. This is where now you combine like terms. Okay? Once again, I'm not doing any FOIL to the bottom here. Okay? So let's see, I got x squared plus an x squared. It's going to be 2x squared. Negative 2x, that's negative 4x. Negative 20 plus negative 16. How are you feeling? That's okay? No.
Oh, I take.
Now what I can do is I can take a 2 out of everything here. Okay, now I can break that bracket down even more. Boom. Now, thankfully, because I didn't do any FOIL on the bottom, I can see that there's stuff on the top and the bottom that's the same now, right? So I can cancel this out. Red, because it's satisfying. Yeah, that's it. You're done. Pump the brakes, Ethan. I like the enthusiasm, but yeah. Now, once again, yes, that was a 5-minute question for me to do. You know, so it's going to be a little bit longer for you guys. You're not going to see a bunch of these on the test, but you need to know how to do this stuff. Okay. Any questions? You guys want to see another one?
Mm-hmm.
Do you want to try one as a group? Like I'll start you off, and then you guys can try it. Okay. Cool. Let's do a subtraction one. X minus 1. Okay, so what I want you guys to do, factor it down and determine what the common denominator is. Don't get it, don't like multiply to get it, but tell me what it would be. Okay, so you'll get your two things. You got x minus 1 here, or x minus 2 there.
Just find any denominator.
Yeah, find the common denominator.
Nothing else.
Not yet.
Yeah, I know.
Yeah.
It's not. I don't. I'm just thinking.
Yeah, so like, so if I factor this one down,
Oh, you got.
yeah, factor both, right? Okay, so common denominator. Let's see. I got an x plus 3 in both of these guys, right? So that's got to be in my denominator. Now, I just list everything. You don't have to do this part here. I just do it so everyone can see what I need. In this one here, I have an x minus 2. Do I have an x minus 2 over here? No. So I need to multiply everything over here by x minus 2, both top and bottom.
Well, are you only doing that because it's a 1 on the bottom? Like on the right side?
Oh no, on this side though, I look, do I have an x plus 1 over here? So I got to multiply both this one by x plus 1. Does that make sense? You lying to my face.
Oh, yeah.
Ethan looks like. Do you understand why I multiplied this one over here by x minus 2, x minus 2?
You do this.
Yeah, it's like whatever I'm missing over here, I have to multiply it over here. I have to multiply. So, and I have to do it to both. I'll be right there, Brendan. I'll see you.
You gave us number 10. It's a word problem.
Yeah. I don't think it's an overly complicated word problem.
So instead of doing the beginning, we're going back to
Yeah.
try to do that.
Guess what? Pistons are just like sunsets. Get your watch to help you there, Brennan. Because the piston goes up, that's the max height, then it comes down, up, right? You'll be fine. Just help me watch. Okay, so does this make sense now? Kind of? Whatever you don't have on one denominator, you have to multiply both top and bottom. Just like if you have fractions. Like if I had 1/3 plus 1/4. My common denominator is 12, right? So I have to multiply both top and bottom by 4, and this one top and bottom by 3. That's what I'm doing here. So this one now looks like this. Oh, let's try that again. X minus 1 times x plus 1 minus and my common denominator is now x plus 3, x minus 2, x plus 1. Okay, so now you do your FOIL here for both sets of brackets. I'm not going to show every step this time. I'm just going to tell you what the answers are. X minus 1 times x plus 1, that's just a difference of squares. minus x squared minus 2 times x squared, or x minus 2 times x minus 2, x squared. Is that okay with everybody? Sam?
We're remaining optimistic.
The eternal optimist?
Sorry for the interruption. This is a lockdown drill. Everybody, please. This is a lockdown immediately.
Okay, you guys have to go into the corner, please. I got the green sign out. Okay. With subtraction, you need to remember this negative sign is going to change the sign on everything.
Like, would it just change it?
Yeah, it's like you're multiplying everything here by -1. It's not the end of the world. It just looks like this now. X squared minus 1 minus x squared. See how I just changed the sign on all of them?
Thanks, everybody. Well done. We are done with the drills for today. There is no fire drill today.
Oh, there it is. I thought we were. Whatever, just take your coats off.
No, don't get on track.
Leave them in here, but just...
She's lying.
That's right. I decided we want to get everyone cold. Okay, so now you just combine like terms. So x squared, take away x squared, 0. 4x, it's just 4x. -1 and -4 become -5.
Are you just like, are you just adding?
Yeah. Did Bree go back? Okay, good. You can go back to work, Bree. We're not doing any more drills. Are you going back, Bree? Or? Oh, I see. Okay. And there's the answer. What's that? It's tough. I'm not gonna lie. This stuff. That's why I was teaching you guys this today. All right. Finding the common denominator is going to be the tricky part. This is the answer right here. Don't worry. That's why you get today and tomorrow to work on this stuff.
Wait,
What?
I don't know. I was confused 104 or something.
Well, 4x doesn't combine to anything. Then I have -1, take away 4, which becomes -5.
So where did the other things go?
What do you mean, like the x squared?
Yeah.
Well, what's x squared take away x squared?
That's all it is.
Yeah. There's nothing here to take out, so I'm done.
Well, the bottom makes sense.
Yeah, okay. So, here's what I want you guys to try today. I want you guys to do on page 336. I'm going to give up the whole assignment, but I only want you guys to do 1 and 6 today. And we'll do 7 and 8. 7 tomorrow. And then I'm going to give you guys more of these to work on. Yeah.
But not 17.
No.
I'm not good at it.
Do 1 and 6, 5 and 7 tomorrow.